Unit 10, Day 2 Notes. Today we're going to talk about arcs and chords in more depth. The distance from a point to a line. The segment from the point that is perpendicular to the line. So for example, if I want to know the distance that point A is from line CD then I would find the distance or the length of this segment here. That would connect A to CD, and it would pass at a specific point. Let's say it's B, and it'll be perpendicular to that line. So again, the distance from point A to line CD is a segment that is perpendicular. A perpendicular bisector is a line that is perpendicular to a segment and bisects the segment. So for example, let's say I have another line. I'll call it CD again. Then line AD will be a perpendicular bisector if it's perpendicular and it cuts it into two equal parts. So AD, or B, sorry, has to be perpendicular, form a 90-degree, and cut the line into two congruent parts. Theorem 10.2 says, in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that is saying is, in other words, if I use my circle here at the right, for example, if arc FG is congruent to arc JH, then chord FG is congruent to chord JH. So these two arcs are congruent, so these two chords are congruent. And it can be read backwards as well. If the chords FG and JH are congruent, then their arcs are going to be congruent. Arc FG and arc JH. Theorem 10.3 says, if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So if I use the circle at the right, the diameter is AB. And the diameter AB is perpendicular to the chord XY. So again, AB is perpendicular to XY. That's the perpendicular symbol, the upside down T. So since they are perpendicular, then we can say XZ is congruent to YZ. And arc XB is congruent to arc BY. So again, what I'm saying on that fact is that this diameter cuts this segment XY into two equal parts. It also cuts this arc XY into two equal parts. Theorem 10.4 says the perpendicular bisector of a chord is a diameter of the circle. So AB is the perpendicular bisector. I know it's a perpendicular bisector because I see the right angle and I see that the two segments have the same equal lengths. So since it's a perpendicular bisector, then AB must be a diameter. So it's kind of saying theorem 10.3 in reverse. So it's telling you that it's a bisector, a perpendicular bisector, so it has to be a diameter. On 10.3, it was telling you the diameter was perpendicular, then it bisects the chord and its arc. Notice 10.4 didn't say anything about the arcs. And then theorem 10.5 says, in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So what that means in our example here on the right is that chord FG is congruent to chord JH, or if chord FG is congruent to FG, then XL is congruent to LY or YL. So if I'm going to say that this chord is congruent with this chord, then this distance from the center should be the same as this distance from the center. And then it must be the same true in reverse as well. If XL is congruent to YL, then the chords FG are congruent to JH. So on that case, on 10.5, it has to be true forwards and backwards. For 10.3 and 10.4, there was only one way to say it. So if chords are the same distance away from the center, then they're going to have the same measure. So the distance from the center was represented by XL and XY. So now we're going to put some of those theorems into use. Number 1 says, in the embroidery loop, segment AB is congruent to segment CD, and it's marked by the tallies, which we can see there. It also gives us the measure of arc AB is 60 degrees, again measured. It wants us to find the measure of arc CD. So one of the theorems previously said that if the chords are congruent, then the arcs are congruent. I believe it was 10.1, but don't quote me. So since the chords are congruent, that means the arcs are congruent. So that means the measure of AB, arc AB, is congruent to the measure of arc CD. So that means the measure of arc CD is also 60 degrees based on that theorem. Number 2, in circle W, arc RS is congruent with arc TV. And again, they're marked with the tallies to further justify that. It wants us to find RS. So since they're telling us the arcs are congruent, then the reverse is true. That means the chords are congruent. And The chord RS is 5x minus 9. The chord TV is 10x plus 3. So again, RS is equal to TV based on one of the properties. I believe it's the same one as number 1. So that means I could set 5x minus 9 equal to 2x plus 3. And this will help me solve for x. So I would subtract 2x on both sides. So I would have 3x minus 9 is equal to 3. Then I would add 9 to both sides, which would give me 3x is equal to 12. And then divide both sides by 3 and get x is equal to 4. Now, go back and read the question. Did it want us to find x? No, it wants us to find RS. But I need x to find RS. So now that I know what x is, I will substitute it in. So RS was 5x, so that's 5 times 4 minus 9. 5 times 4 is 20, and 20 minus 9 is 11. So RS is equal to 11. It doesn't provide the actual unit, so we could just say 11 units. Number 3, in circle S, arc PQR is 98. So let's highlight that. PQR, that whole thing is 98. Find the measure of arc PQ. So we're looking for this arc here and only that arc. SQ represents the radius, and the radius is perpendicular to PR. And one of the theorems said that if the diameter or the radius is perpendicular to a chord, it'll bisect the chord and the arc. So in other words, PT will have the same measure as TR, and then PQ, the arcs, will have the same measure as QR. So knowing that fact, I know that this is PQR represents a whole. And it's made up of two parts, PQ plus QR. So again, this is part plus part equals whole. I know the whole is 98. I don't know the part. And the two parts are the same. So if you have part plus part, it ends up being two parts because they're the same. So if I divide both sides by 2, I will know what one part is. So 98 divided by 2 is 49. So that means PQ, or the measure of PQ, is 49 degrees, because it would be half of PQR, which is the whole thing. And number 4, which is the last one. In circle A, WX is equal to XY. So I'm going to put a tally on the picture. And they're both equal to 22. Find the length of AB. AB is represented by 5x. So since the chords are the same, that means their distance from the center, which is A, is also the same. So 5x is going to equal the same thing as 3x plus 4. So what I'm saying is the length of AB is equal to the length of AC. So that means I could set 5x equal to 3x plus 4 and then solve for x. First, I would subtract 3x, which gives me 2x equals 4. Then divide both sides by 2. So I would have x is equal to 2. But again, it doesn't want me to find x. It wants me to find AB, So that means AB, which was 5x, that's 5 times 2. Sorry, getting ahead. So that would give us 10. So AB is equal to 10. And this concludes your notes for today.